Hi folks, we're going to take a look at the solution for page 233, number 15, okay? So they give us that an angle theta lies in the second quadrant, so between pi over 2 and pi, and has a sine value of 7 over 25. Okay, and part A asks us to determine cos of 2 theta, and in fact asks us for the exact value of cos 2 theta. Okay, now here I want you to think about how this can be done without having to really do much other work. Because remember that when we've got the cosine double angle, we have the option to rewrite that in terms of either sine or cos. Since I know the value of sine theta, I can just rewrite this expression here as 1 minus 2 sine squared theta. Okay, and since I know what sine of theta is, I can just calculate it without really doing much work here. So 2 times sine theta is 7 over 25, so squared. And now really the toughest part is just doing the algebra here. So here I got 1 minus 2 times 49 over 25 squared is 625. Okay, here I'm going to have a fraction over 625, so I'll turn 1 into 625 over 625 minus, and this is 2 times 41 is 98 over 625. And so here we've got, let's see, 15 minus 8 is 7, 11 minus 9 is 2, and 5 minus 0 is 5. Okay, so 527 over 625. Okay, so again, in this case here, because we already had sine theta, and I can write cos 2 theta in terms of sine theta, I was able to calculate it pretty easily. Okay, let's go to B now. In B, they're asking you to determine the value of sine 2 theta. Okay, and we don't quite have the same luxury with this case here, because there's only one version of sine 2 theta, and that's 2 sine theta cos theta. Okay, so we're good with the sine theta. We already know that's 7 over 25. We just need to find cos theta. Okay, but we've seen this before, where with the information that we're given, we have enough in order to determine cos of theta here, because I know that the angle's in the second quadrant. Okay, so theta is somewhere in the second quadrant, and I know the sine value for this. So here it means that my y value will just be 7, and my r value will just be 25. Okay, so in order to determine that horizontal value, I just have to use Pythagoras. So that's just going to be the square root of 25 squared, which is 625, minus 7 squared, which is 49. Okay, and that's just equal to the square root of 15 minus 9 is 6. 11 minus 4 is 7, and 5, so square root of 576, and that's actually a nice square root. It's just 24. Okay, but here, since this is on the negative side, this is going to be negative 24. Okay, and so now I can just calculate sine of 2 theta. So it's 2 times sine theta we already knew was 7 over 25. Okay, and then cos theta we now have is negative 24 over 25. Okay, so here what do we have? We have 7, that's 140 plus 28, that's 168 times 2 is 336, so negative 336, I believe, over 625. Okay. Now, by the way, just a little quick check here. Since theta we know is in the second quadrant, okay, somewhere in this quadrant here. Well, if I double pi over 2, I get pi. Okay, and if I double pi, I get 2 pi. So that means 2 theta is somewhere in the third or fourth quadrant. Okay, so we can't really say for sure where it's going to be, but you know, the fact that the cosine is positive means that it's likely in the second quadrant. Okay, and in fact here, if we've got sine 2 theta negative, well, we know that in the fourth quadrant it's also negative. Okay, so these answers, you know, more or less make sense. I could probably be a little more precise by using, these three sides, I see that because the 24 is much larger than the 7, this angle is actually much, much closer to the x-axis. So when I double it, it makes sense that it'll be greater than 3 pi over 2. Okay, so again, not that it was necessary to think about this to do this problem, but it's just nice to kind of make sure everything all makes sense. So that does fit that cos 2 theta is positive and sine 2 theta is negative. Okay, that's it for this one.